Volume, grades 6 through 8. I figured that would be important to kind of cover all three grade levels, considering the stuff we've already gone through. Like, you already kind of dipped into the 8th grade stuff. But what I want to do is be very specific about what we're going to be doing. So whenever we're talking about an 8th grade emphasis, which is down here, these are the things that you learn in 6th and 7th, and they just add a couple circular things in there, like a cone, a cylinder, and a sphere. And those are on the formula chart. But the main thing they want you to do is solve problems with them. So, like an example would be, say that you have a corn silo. It's in the shape of a cylinder, and it's filled up halfway if it were 100 feet tall and 50 feet wide. What is the amount of the cylinder that is filled? And so you'd have to find the volume of half of it. The idea of what we're doing is completely about volume. We'll do something else separate with surface area, but by far using the formulas for volume, just consistency, organization, writing, and rewriting. This is the 8th grade formula chart. It's not all of the formula chart, but it's the part that's relevant to what we're going to be doing. I highlighted volume and area. You can see down on the volume section that there's a capital B. There's a capital B. That capital B is going to directly reference the area. So area of the base. And we're going to go through and we're going to define what is the base of a three-dimensional figure. How do you determine that? What's a foolproof way of identifying the base of a three-dimensional figure? Then we're going to go over how to find the height of a three-dimensional figure and the differentiation between the height of a three-dimensional figure and a two-dimensional figure. So these area problems are a prerequisite. You have to know how to be able to do area to be able to do the volume section, because half of almost the entire formula for volume is finding the area of a shape. So both these, and the reason I have capital B here is because all of these shapes in the area section are capital B. Find the area of the base, and that's going to be one of these shapes. So for each of these, I'm going to go over the anatomy of the type of prism or the three-dimensional figure we're looking at. I want to really emphasize what the base is and what the height is. So there's only two sides that are parallel on this triangular prism. And the reason I named it a triangular prism is because you identify it by its base and it's connected by rectangles on the sides. So there's 3 rectangles connecting 2 triangles together. Those 2 triangles are parallel. That means they're never going to touch. That means they're across from each other and they're both pointing upward in the same degree, angle, and everything. So whenever these 2 things are connected by rectangles, it makes it a prism automatically. We could put a trapezoid instead of the triangle and connect it with 1, 2, 3, 4 rectangles, and then that would be a trapezoidal prism because it's connected by rectangles, 2 parallel sides connected by rectangles. So we automatically know that we have a triangle. And the process I'm going through right now and talking about this is exactly the process you should be going through whenever you're identifying a three-dimensional figure. So I know that I'm going to be finding the area of a triangle. And the height of every prism is going to be the distance between the 2 bases. So the distance between the 2 bases, there is your H. So prism, boom. We are talking about a triangular prism. Triangle, prism. Now, what I'd like to do is I'm going to go to the next slide. It's going to have the same exact triangular prism, except it's going to have numbers on it. So what I'd like you to do is whenever I go to the next slide, hit pause or hit the space bar to pause the video and try and work out the problem. The thing that we're going to go for is not only just the answer, obviously, but the process in which you're going through and organizing your work to make sure that you're getting this stuff done. Whenever you get into three-dimensional figures with surface area and volume and you start throwing in algebra, your work organization is going to be critical to you being able to keep up with what you're doing. This would be an opportunity to pause the video. This is a triangular prism, and I've identified the height of the triangle, which is the base, and the height of the prism, the distance between the bases, is going to be 40. So please pause the video and hit play whenever you completed everything and you're ready to rock and roll. All right, so assuming that you pause the video, I'm first identify this as a prism, and it's going to be a triangle as the base. So I know that V equals B times H, capital B times H. This is where the organization of the work comes in. So capital B, I'm going to go ahead and take this, and I'm going to rewrite it over here. So B equals half base times height, or base times height divided by 2. Anytime you see a fraction there, you can always just, and whenever we get into spheres, it'll become more clear. But if you have half of something, it's the same thing as dividing by 2. So the base of the triangle, let's just focus on the triangle right now, okay? The base of the triangle, little baby b, is 10. So we have 10 times the height of the triangle, which is the dotted line, and we know it's the height because it shows us from the base to the top of the triangle, and we have a right angle there. The height is always going to be an h. You can see it right here. There's the h. It's like, I'm the height, use me. Okay, fine. So now we have a height of 14. And we're going to divide that by 2. You can see how I'm rewriting the entire thing. I wrote the formula, I substituted the numbers in. I'm going to simplify one step at a time. Capital B equals 140 divided by 2. Capital B equals 70. And why am I doing it that way? Let's just go ahead and say you already have the answer on your page, okay? And you don't have the organization of this work, and you're taking it piece by piece. What if you made a mistake? How are you supposed to go back and check the entire problem? You can check a piece at a time. It's way easier than redoing the entire problem and arriving to the same incorrect answer. So currently we have volume equals 70 times the distance between the bases, which is the distance between the triangles, which is 40. Okay? So 7 times 4 is 28 with 2 zeros. 2,800 units cubed. So we have 2,800 cubic units, approximately, based on the information that we were given. I'm going to go ahead and use a calculator just to make sure. 2,800. Cool. So you can see how I took one piece of the equation and moved it over to the side. And then I took my answer right here, 70, and multiplied it by the height. This is the type of format I would look for as a math teacher, and this is the type of format I would grade you on. I would probably give you the answer of 2,800 and say, I want you to match the format. Organization of work when you get into more complex math is critical. Okay, what the heck? It looks like an Amazon box. So the reason I color-coded these is because I want you to be able to choose. The answer is going to be the same regardless of which base you choose. But just know that whichever base you choose, you're looking for the opposite side. That's going to determine your bases and also the distance between them, the height. So right now I know that we currently have a prism, and it looks like a rectangle. Out of all the shapes I have to choose from, definitely not a triangle, a parallelogram, trapezoid, or a circle. So check, check. Now I'm going to write the formula. volume equals capital B times H. I'm going to go ahead and take my capital B, go over here, mind my own business. So capital B is going to be of a rectangle, which is little base times height. So you can see how I'm already going through it. I don't even have numbers yet. I'm already breaking it down. So what I want to do is I want to choose what I'm saying the base is. What I want to do is choose the orange ones. I'm going to choose the orange ones. If you want to choose the blue ones, choose the blue ones. Our work's going to look a little bit different, but our answer should be exactly the same. So highlighting the orange ones in blue, there is going to be our base. The distance from the first base to the second base, or our one set of parallel sides, is going to be your height. So here is your base, and here is your other base. This is going to be the height of your base. Okay. So whenever I change it to the next one, there's going to have numbers on the same shape. I want you to be able to write the formula, substitute in capital B for the appropriate area formula, simplify those step by step, then break it all down and put it over on the left side, come up with an answer, and make sure you're using the correct units. Now would be the time to pause the video. Okay, assuming that you paused, what we're going to do is we're looking at a rectangle and we're looking at a prism. Definitely not a cylinder, not a pyramid, not a cone, not a sphere. So if you have to go through the process of elimination to get that, that's perfectly fine. Capital B times H, taking my capital B, I'm going over here, minding my own business. Capital B equals baby B times baby H. Okay, so what I said I was going to do was I was going to choose the orange as my base. And there's only two dimensions to a base, which is length and height, or width and length, or width and height. Length and height, base and height. Either or, they're all the same. They're interchangeable. It's 18 by 6. So capital B is going to be taking 18 and multiplying by 6. Base, the bottom of that orange rectangle, and the height of the orange rectangle, giving us a total of 108 square units. The reason it's square is because we had 18 rows divided in, or 18 columns divided into 6 rows, giving us 108 square units. So I'm going to go back over, and I'm going to do my capital B as 108. The distance between my bases that I chose was 20. Now we simplify that step. We have 2,160. 2,160 cubic units. Now here's the difference if you'd have chosen blue. If you'd have chosen the blue as your base, you would still have a 20 by 6. So 20 by 6. Then you have 20 times 6 give you 120. And then you'd be multiplying by the height of the prism, which is the distance between the blue, which is by 18. So you'd have 120 times 18. I'm just going to go ahead and double check, why not? 120 times 18. And you get 2,160 cubic units. If for some reason you're doing these problems and they look different than what I'm doing, please take a moment on the next one and focus on the format. So far what we've done is a review. We're going to start getting into the more complex figures, and hopefully the explanation that's given by just utilizing the formula will be good enough in itself. So we can see here that we have a base on the bottom, which looks like a square or a rectangle. Let's just call it a quadrilateral. And we can see that on the opposite end of it, it comes to a point. There is not another shape exactly like that one. So this would make it a pyramid. Anytime you have a shape on the bottom and every side of that shape is connected by triangles, that makes it a pyramid. So let's go ahead and say that we currently have a rectangle as the base, because that is the thing that all the triangles are connected to. And it looks like we have a pyramid. The thing that I was talking about earlier whenever it comes to the 1/2 baby b times h is whenever we get into volume formulas that are talking about 1/3 the area of the base times the height, that is the same thing as saying, all right, so if I put this over 1 and I multiply these, which is what I'm doing anyway, I'd have 1b times h. 3 times 1 is 3. So taking 1/3 of something is the same thing as dividing by 3. I'm pretty sure you're familiar with that, but I just want to make sure that whenever you're looking at a formula, if you're thinking 1/3 of something, just think of multiplying the numerator by everything to the right of it, and then keeping the denominator on the bottom. And whenever we get into a sphere, that'll become more and more clear. So whenever I change the slide, it'd be a good time to hit the space bar, hit the pause button, and work through the problem yourself. Keep in mind that a pyramid is the same thing as a prism, except it's 1/3 of the volume of the prism. So if we were to have this quadrilateral on top and then we had it connected by rectangles, we would have another prism. Now if we shave off 1/3 of that prism, it turns into this pyramid. So keep in mind anytime you're dealing with 1/3 of something, you're dealing with something that is not quite perfect, but it's something that is an approximation. Just know that we're dealing with about 1/3 of the volume of its prism counterpart. This is all the information we need to find volume. So obviously this is going to be a square base, which is going to fit in with rectangle and still a pyramid. Please pause the video, take a moment, work through the volume formula, take the capital B and place it over on the other side. Just have them separated, work your pieces out, go. Okay, so we agreed. Yes, I know, I asked you and you said, yeah, definitely a pyramid. So I'm going to go area of the base times height divided by 3. If you want to do area of the base times height and then divide it by 3, cool. Just make sure you're showing that process. I'm going to take my capital B, I'm going to mosey on over with my capital B equals baby B times H. So the thing that is obvious about this is we're dealing with a square. The reason I know that is because we're only talking about, two sides, a base and a height, but we're only given one number. That would make this 9 as well. So simply put, we have base times height, which is 9 times 9. There is no option to choose a base on this one. The only option you have is the single base that you were given. That is the one that is connected by triangles all the way around it. So your area of your base is going to be 81 square units. Once we take our capital B and plug it in over on the other side, then we're going to multiply it by the height of the pyramid. So the reason that we're separating it also is because look at how similar these are. Capital B equals lowercase b times lowercase h. Capital B times lowercase h. Come on, how am I supposed to keep up with this? Separate them out. So now we're talking about h in the volume formula. That's going to be where the right angle sits. Look at that. There it is. It's even making a backwards h. There it is, the height. It's going from the base that we chose, the one that we were given, all the way to the top point of where the triangles meet. That is a total distance of 8 units. And I'm going to have that divided by 3. So you can see here, I'm not going to do 2 of these steps at the same time. I'm not going to do 81 times 8 and then divide it by 3 and write the answer. I'm going to go the long way because I want to know that I'm doing each step correctly. So I did 81 times 8 and got 648. Now I'm rewriting that as divided by 3. This is where our answer is going to come in. 216. Approximately 216 cubic units. So if we were to think about its prism counterpart from which this pyramid was created, then we would take 3 times this amount and we'd have basically almost a cube, since we have 9 by 9 by 8. Okay, the cylinder. Cylinders aren't really that bad, other than you know that you're dealing with a circle. So let's just go ahead and get that out of the way, and we're talking about a cylinder. You can see that cylinders fit into the same category as a prism because really all you're doing is finding the area of the base, which is capital B, and then multiplying it from the distance to the other end, which is the other base, also known as the height of the cylinder. So the reason I put two of them here is because it's important to constantly recognize and go over and over and over. This one is a radius. This one is a diameter. You can see that there is nowhere over here does anything have D for diameter. So that means you need to be able to figure out, all right, if I've got a diameter going all the way across, and keep in mind diameter is a longer word, longer line, radius is a shorter word, shorter line, that I have to figure out what half of my diameter is. So whenever you have a diameter, just cut it in half. If it were 10, now the radius is 5. This is the formula you have to deal with. You cannot use a diameter in that formula. Just cut it in half and you have the radius. Other than that, this is the height, good to go. What you need to do is pause the video and take an opportunity to go through this yourself. Please separate out the work piece by piece. Don't skip a step, one operation at a time, rewrite, go. Okay, so we established that we're going to talk about a circle and we're talking about a cylinder. Capital V equals capital B times H. I'm going to just take my capital B, mind my own business. I'm going to go capital B equals pi r squared. Whenever you get into 8th grade, they're going to tell you to use 3.14. Typically in 6th and 7th grade, you can get by with using 3 as estimating, and like everybody's okay with that. Whenever you get into 8th grade math, there's going to be 3.14 or the pi button on your graphing calculator. The pi button is going to give you the most accurate answer, but they're still going to ask you to round to the nearest hundredth, maybe even thousandth. So just keep in mind that 3 is out of the game. You're going to be using 3.14 or the pi button. I'll be using 3.14. So let's see. Okay, radius. I just want to be clear. I'm identifying all these pieces. Radius is 6. All right, so 6 squared. And I've got 3.14. I like to rewrite pi as what I'm using. If I were using the actual pi button for the calculator, I would keep the symbol of pi because that's what I'd be using. But since I'm using 3.14 as pi, I want to write 3.14. The only thing that comes in with circles is order of operations. You want to make sure that you're using the order of operations. For example, do you see parentheses? Yes. Or is there anything to do inside of those parentheses? No, it just says 3.14. Okay. Next. Do you see exponents? Yup. So that means this is what we got to do next. 6 squared. That is a very simple mistake that gets made often. Now that we've simplified it, and this is why we go one step at a time, we can see that we did the first thing first. We didn't just mix it all together. So now I'm going to type in 3.14 times 36 and get an area of the base of approximately 113 and 4/100 square units. There's my capital B. So all of that just found that circle, the area of that circle. Now think of that having 10 times it stacked up. So think of this as being like a penny. And it's 1 unit tall. And we stacked up 10 pennies. V equals 113.04 times the height, the distance from circle to circle, which is 10. So you could use mental math. You could move the decimal 1 time over and have 1,130.4. But I'm going to go ahead and just be thorough and multiply by 10 just to make sure no human error is involved. Cubic units. So far, Not much has changed. It is the idea of using a volume formula and separating the area piece out, and then taking the answer and putting it back in. If you have stuff all over the place, you're going to get lost. That's the last thing you want to do when you're dealing with geometry and crunching numbers. Cone. Whoa, this looks like a pyramid, but it's not, because the base is no longer a quadrilateral. The base is a circle. So if you have a circular base and you do not have another circular base parallel to it, you are now looking at a cone versus a cylinder. And much like whenever we were talking about prism to pyramid and how it was 1/3 the volume, cylinders and cones are much the same. So a prism's volume is to a pyramid's volume as a cylinder's volume is to a cone's volume, approximately 1/3. So what we're going to end up doing is making something almost identical as what we just did, but then taking the answer and dividing it by 3. So cones, same exact thing as a cylinder. Divide your answer by 3. Easy peasy. And I would be silly to not mention again radius in diameter. You are going to be dealing with a radius. It pays to know that when you have a diameter, you cut it in half, you have a radius. Diameter is the longer word, it's the longer line. Radius is the shorter word, it's the shorter line. What we're going to do next, and I would be silly to skip this part as well, the H. Where the right angle sits is the height of your cone. Bam. So, pause, go on to the problem. Now you should pause. If you paused when I said to pause, then you'd be looking at not this. So now you should pause. Use the volume formula. You're talking about a circle and you're talking about a cone. You can see how the things are very similar. Go. Okay, so we're looking at the volume is area of the base times height divided by 3. Well, I'm going to take my capital B, of course. It's just like, all right, quit saying it already. But it's like, I can't, because it's the same thing over and over. Pi r squared. All right, do I have a radius? Yes, that radius is 4. Okay, so B 3.14 times 4 squared. So again, whenever you see exponents, you automatically need to go PEMDAS. Do I see parentheses? Yes. 3.14. Is there anything to do in there? No. Then exponents. Yup. 4 squared. That is not 4 times 2. That's 2 4s being multiplied together, not 4 2s. Okay. So B equals 3.14 times 16. Breaking it down, one step at a time. One step at a time. 3.14 times 16 gives you approximately 50.24 square units. And I keep on putting the units because whenever I'm looking at my work, if I think I made a mistake, then I can go back and go like, all right, it says units squared. Because if you accidentally put units cubed there, then you think you're pretty much done. And you could be looking for A, B, C, or D, 50.24, filling in 50.24 on a griddable. And it's not even be close. You're halfway done with the problem. I'm going to go ahead and take this 50.24 and plug it back into my volume. 50.24. And let's look where the H is. Okay, so there's my height. From the center of the base all the way up to the highest point. There's my 5. Okay, so times 5 divided by 3. Hey, order of operations applies to all math at all times. And the reason why I'm saying simplify one step at a time is the order of operations. If you try to do all 3 of these at once, because they're of equal and opposite power, it would work. But what you want to do is simplify one step at a time so you can avoid mistakes like that. So if you're consistent with the process that you're using, you will avoid mistakes in the future that you don't even realize that are there. So 50 equals 50.24 times 5. So that's 251. Notice I did not divide by 3 yet, because I don't do that. Divided by 3. 83.73 repeating cubic units, and I'm boxing in my answer every single time. That's where I know that I've finished. So if we were to have kept the same numbers for the radius and the height as we did for the cylinder, then you'd notice that the volume is exactly 1/3 of the volume of that cylinder that we did earlier. Since they're not the same numbers, it's not, but if you wanted to know what its comparable cylinder shape volume would be, then multiply the volume by 3, and then you have the volume of a cylinder. Whoa, it's like a circle. No, it's not a circle, it's a sphere. All right, and if you want to get on a math teacher's nerves, call it a ball or a circle. Ugh, it's terrible. All right, so you can see that there's a circle going around the center of it. That is relevant. But going around the center of it, around the center, which also has one going around the outside of that circle, gives it the three-dimensional feel. So we're still talking about a circle. Obviously, we're not talking about triangles, rectangles, parallelograms, or trapezoids. And now we're talking about a sphere. This formula gets a little wonky. And the only thing that's wonky about it is you're talking about the radius cubed, and you have 4/3. So it's like, what? Just so we're clear, whenever we're talking about 1/2 base times height at the very beginning, talking about the area of a triangle, this one we have 4/3 pi r cubed. That is the same thing as just putting this as a fraction, putting 1 underneath it, going 4 times pi times r cubed, 4 pi r cubed. And then 3 times 1, 3. So this is the formula I'm going to be using. It's going to simplify 3 times on top before I ever divide by 3. So whenever I change the slide, hit pause and go for it. See how close you get, and then let's compare. Whoa, where are the rest of the numbers? Just kidding, there's only one. All right. So whenever we're talking about this, you could sit there and go like, okay, hold on. Why do I need this circle formula? How am I supposed to put that in there? Isn't that supposed to be capital B? Didn't you have a big capital B right here? I did. Now I want to take this, and I want to look. Think about this. This was for 2 dimensions, x and y, okay? This is for 3 dimensions. Whenever we're cubing dimensions, we're talking about a 3D figure. You're going to do the same thing with a cube. If you wanted to find the volume of a cube, you'd have V equals S cubed. Side times side times side. That gives you length, width, and depth. That's going to be the same thing with a circle. So the catch to a sphere is all you need is this. That formula takes care of a 3-dimensional circle or a sphere. So let's go ahead and write that formula down and break it down. Because if you're confused about how to use the circle in this, good. Because that means you're not on autopilot. That means you're trying to figure out, how am I supposed to use a 2-dimensional figure to come up with a 3-dimensional volume when it's 1/2 of a line? Keep in mind this is also a radius. You'll be given spheres with a diameter. So 4 times pi r cubed divided by 3. Okay, so V equals 4 times, I'm still using 3.14. And the reason I'm using 3.14 is because I used it on all the other ones. The radius is 10. And we're still dividing by 3. All right, here we go. So we have 2 sets of order of operations. We have a numerator and denominator. First, you'd always want to simplify your numerator, then simplify your denominator, and then the last thing that you'd want to do is the division that separates the numerator and denominator. It appears that we have things to do on top. This is where PEMDAS comes into play. Do you see parentheses? Yes, I do. But there's only 3.14 in there, so there's nothing left to do in there. Okay, that's fine. Do you see exponents? Yup. That's 10 to the 3rd. So 10 times 10 times 10, 1,000. V equals 4 times 3.14 times 1,000 divided by 3. Go ahead and just drop this over here. Now I can just solve from left to right. Since everything's of equal and opposite power, I can just multiply, and then once that's done, divide. I'm going to start from left to right. So 4 times 3.14, which is 12.56 times 1,000 divided by 3. One step at a time, I'm telling you. Once you get into Algebra 1, Algebra 2, and you're skipping steps and you're trying to do mental math, you're going to get lost. Take my advice. Times 1,000. That's going to be 12,560 divided by 3. I mean, really, are we really doing that much extra work? I mean, really? No, we're not. We're being thorough, and we're making sure that we are doing calculations. We're doing an absolute science, and we're doing it absolutely absolute. Cubic units. And the 6 was repeating. It should have been repeating on your calculator. If it wasn't, you made a mistake. So this is the most complex one when I think about it as like an idea, or the differentiation between a prism, a cylinder, a pyramid, a cone, finding the area of the base, going the height, just rinse and repeat over and over and over. This is the only one that stands out. So there's going to be some links that you can practice volume on. And the thing that I want to emphasize is the format and one step at a time. I know you struggle with that, and that is something that needs to get done, something needs to get fixed for you to be successful. Also, there's going to be some work sent over for you to practice, and that practice is going to be volume. And what I want to see on that is the format correctly done. If you need to review the video again to get the format, please do. And then I'd like to check it. And if you have a question over any of them, please send it my way, and I will go through the process again.